So, good afternoon, all of you. Today is the first lecture of your B classes. Okay, and in that, this is our first lecture of professional related subject, that is non-conventional machining. Okay, for both division, non-conventional machining subject is compulsory. Okay. Now, let us start with the, as per our tradition, we will cover the one by one all points. Okay, so you know the name of our subject, non-conventional machining. Okay, in if you see the syllabus of this subject, it is similar to advanced machining processes subject. Okay, so you can call this subject as a advanced machining process or non-traditional machining process. Okay, so NCM or NTM both are same, or advanced machining. Okay, now as per our policy, you should know the who is your subject teacher. Okay, so you can see on the screen, so myself, Professor DT Kashif. Okay, now this is your first batch to whom I'm teaching this subject third time, and already last semester I have taught this subject to third year students. Okay, now this subject is for your final year second semester. Okay, and first time I am dealing with your division. Okay, so you should know the my introduction also. Okay, before that, whether my voice is audible, please give response. Rohan, say yes or not so that I can proceed further. Okay, okay, so I am Professor Vitikashit. I have completed my Master of Engineering in Heat Power Engineering. Okay, that is my specialization under Mechanical Heat Power Engineering. And till today, I am having the teaching experience of 6 years. And in this my tenure, I have taught different subjects. Okay, like applied thermodynamics, then numerical method, heat and mass transfer, fluid machinery, fluid power, then power plant and energy engineering. Okay, these are the thermal group subjects, and apart from that, I have taught some production group subject also, like production and operation management. Okay, that subject I have taught three times. Okay, for final year students. Okay, during last 3 years. Then this is our non-conventional machining. Okay, so again this is my third time to teach this subject. Okay, and for MTech I taught computational techniques in design engineering. So these 8 subjects I have taught in my teaching career. Also, I have published during this academic career, I have published different research papers in different international conference. Okay, so a total 15 research papers I have published. I have attended as well as presented five interest five research papers in international different international conferences. Okay, as well as five papers I have presented in national conference also. And apart from this, I have attended more than 20 short-term training programs, faculty development program. Okay, to improve the my skill or knowledge. Okay, to upgrade the knowledge also. Okay, so that training programs also it is important for subject teacher or the professor. Okay, along with this FDPs, I have attended different workshops, seminars. Okay, that total count is still today 15, 15. Then during our this pandemic situation, I have attended different courses. Okay, like you, that Coursera and other some professional career enhancement program. Okay, so like that, near about 9 different courses I have attended. Okay, and on my MTech thesis, I have published one book. Okay, in Lambert publication. Okay, that is free of cost. You can also publish your BA thesis or other work in that Lambert publication. Okay, it is uh, free. Okay, so this is my small introduction. Now, if you want to contact me, so for that I have given my contact also here. Okay, 9168 655335. Okay, this is my contact number. Okay, you can call me or you can give me a WhatsApp message also. Okay, this is my permanent number, and for official mail purpose, you can note down this my mail ID also. Okay, so dtkashid@coe .swery.ac.in. Okay, so that is you know. So this is my introduction. Okay, now don't think about that. Why you have chosen this subject, or why we need to learn this subject. Okay, on that point, I'm going to deliver one lecture. Don't worry. So after this, all the points, I'm going to start with that point. Okay, before first point of our syllabus, I'm going to teach you that why we are going to learn this NCM, or why we need this advanced machining processes. Okay, now for any learning of new things, or for there is some we should have the aim, or we should have some motivation behind the every activity or everything. So for our subject, if you ask me what is the motivation behind the teaching this subject, or if I will ask you any general things why you're learning this subject, then from my side I can tell the one philosophy line. So that is a, here I have written that education is a journey, and so that we have to learn. So let's enjoy it. Okay. So this is just a journey of your life. Okay. Education is the part of the journey. So that we have to enjoy. So this is a motivation you can call, or the philosophy behind our learning of this ENSM subject. Okay. Or you can call motivation also. Now, what is the prerequisite of this our non-traditional or non-conventional machining subject? Okay, so you know, in our in your second year, you have learned the manufacturing process subject. Okay, then in third you have learned metallurgy subject. In fourth you have EMT subject. Okay, you have gone for the different processes, manufacturing processes, as well as some different uh, different material. Okay, so in EMT subject, you have learned about the traditional machining processes. Okay, now the basic question arises is that what is meant by traditional machining process, or what is meant by the conventional machining process. Okay, so for that I will take the one example. Simple example. Let us consider we have the workshop, and in our workshop we have the near about 30 lathe machine, then drilling and other milling. Correct. So to to do the facing that operation, or the you can consider another turning operation, you need a one sharp tool. Okay, and you have to give the that physical force. Okay, so that tool should be physically contacted with that your job. Okay, and then if you apply the force, and if you rotate your job with the help of the your that cylinder. Okay, so then and then only your that operation will complete. It will remove the material. Correct. So for the machining, or the to remove the material, we require, or you require the that tool, and that tool should be physically contacted with the your job. Correct. By applying some force. Okay, without applying force, it is not possible to remove the material from your job. Correct. So for conventional machining, you require the physical contact between your workpiece, okay, and your tool. So that whatever you have learned the that machining process in the your MP subject, that are the traditional. Okay, so that knowledge is required. Okay, now that traditional knowledge is required, and by going by advancement of that, we have the advanced machining process, where there is a no physical contact between the your job and your tool. Okay, so how that operation will perform without physical contact. Okay, so that part we are going to learn in our subject. So prerequisite, we should know the some basic knowledge from your machine technology subject or manufacturing process, as well as we should know the some different energy sources background. Okay, we should know the some different energy sources. Now, which are the energy sources? We know the mechanical energy, okay, thermal energy, chemical energy, okay. So that all we should know. Okay, now using this different energy sources, we are going to remove the material from the your workpiece, okay, without tool, without physical contact of your tool, okay, to the your workpiece, okay. That is the some history part or prerequisite which is required for our subject. Now coming to the our syllabus, okay. So as per the our university syllabus, okay, that is with effect from the 1920, from last year. This syllabus came for you. So for our non-conventional machining, okay. Once again, I will tell, as per the syllabus of university syllabus, our subject is a professional relative. Okay, there are different options are given. Out of that, you have chosen the non-conventional machining. That is C option. Third option you have chosen. Now for our non-conventional machining subject, we have the 70 marks of end semester exam. That is university exam. Okay. Now we don't right now we don't know about the whether end semester exam of will be of 70 mark or the 50 mark, whether it is offline or online. Okay, that is we don't know. But as per the syllabus, I'm telling that 70 marks are for end semester exam. Then as usual for end semester exam, we have that is ISC 30 marks. Okay, and for term work, okay, internal continuous assessment. Okay, so for ICA, we have the 25 marks. Okay, as usual, you know that for ICA also, we have some different policies, that assignment, journal, and other things. Okay, oral part is there, and attendance also important. Okay, so and out along with this, for our subject, we have the oral exam. Okay, university or that is external oral exam. And for that, 25 marks are there. Okay. So total 150 marks are there for our this subject, non-conventional machining. Now for our this non-conventional machining, we have the two sections. Under section 1 we have the 3 chapters, and for under this section 2 we have the 3 chapters. Okay. So first chapter name is overview of non-conventional machining. This is just an overview of all the chapter. Okay, in that we are going to see the what is meant by non-conventional machining. Okay, then classification of different non-conventional machining processes. Then comparison between your traditional machining and non-traditional machining. Okay, and then after classification of non-conventional machining, we have the separate chapters depending on the your classification. Now that separate chapter means what? Separate means what? Depend on the energy used for the material removal process, we have the classification. So depend on that, we have the chapter number 2, that is unit number 2, that is mechanical energy based processes. Okay, in detail syllabus I am going to tell you. Then third chapter will the electrical energy based processes. Okay, so these are the 3 chapters or 3 units belongs to the section 1, and in section 2 we have the 4th, that is chemical and electrochemical energy based processes. Then 5th, thermal energy based process. Now chapter number your 3rd, okay, and your 5th, actually both are combined as per the standard. If you go by the advanced machining process reference book or other thing, then the syllabus of this, it is combined. That means the here we can call thermoelectric processes or thermal sorry electrothermal energy processes. Okay, so here we are going to learn EDM, that is electric discharge machining. Then wire electric discharge machining. In thermal energy, we are going to learn laser beam machining, plasma arc machining, ion beam machining, okay, and electro beam machining. So actually that is combined part, because for EDM we require electric energy, and that electric energy is going to convert into the thermal energy, and through that thermal energy or heat energy, your material removal operation is going to happen. Okay, so again for the your laser beam machining, if you take the example of laser beam machining, there also we need the electrical energy, and that electricity energy is going to convert into the heat energy, and through that heat energy your workpiece from your workpiece material is going to remove. Okay, so but as per our syllabus we have separate name like thermal energy based process and electrical energy based processes. Okay, and so these 5 chapters are related to only non-conventional machining process. Now, out of this, or we can say, so apart from this 5 chapter, we have the additional one chapter that is called Introduction to Coating Technology. Now, this chapter totally belongs to the your surface engineering. Okay, so if you know the that surface engineering is the stream of our mechanical engineering. Okay, if you go COP, so their surface engineering of coating technology is separate branches there. Okay, oil coating separate. So again, this chapter 6 is just a introductory chapter is there. Okay, just a in that we are going to learn some classification and some methods. Okay, CVD, PVD. Okay, in detail we are going to take. But this introduction to coating technology, it is a different from this your all other non-conventional machining processes. Okay, so this is just a overview of your syllabus. So now let us go for the in detail syllabus. If you will see the in detail syllabus of each and every topic. Okay, now first unit is our overview of non-conventional machining. Okay, so in that unit number 1, we have the unit content like need of non-conventional machining processes, then classification, then comparison of your non-conventional machining processes with conventional machining processes. Okay, and then at last we are going to take the brief overview of all the technologies. Now, all the technologies means what? Whatever technologies or whatever the processes we are going to learn in chapter number 2, chapter number 3, 4, 5. So the overview of that we are going to learn in the chapter number 1. Okay, so as per the syllabus, university syllabus for this chapter, university has given the 4 lectures. Okay, so this is the content of your chapter number 1. Now this is the second chapter. Okay, mechanically energy based non-conventional machining processes. Okay, now how this mechanically based non-processes classified from our conventional, that we are going to learn in the chapter number 1. Okay, or in the first after the syllabus dictation, I am going to take our non-traditional or non-traditional, or we can call advanced machining process. This is first category. Depend on the which energy source you have used for the removal of the material from the workpiece. So this is the first category. Okay. Here we have used mechanical energy for what purpose? To remove the material from whom? From your workpiece. Okay. Now in this chapter we are going to learn 4 different processes, advanced machining processes, or we can call non-conventional machining process. So first process will be the abrasive jet machining. Okay, abrasive jet machining. Then second will be the water jet machining. Okay, then combination of this abrasive jet and water jet, that is the abrasive water jet machine. This is third process or technique you can call belongs to the this mechanical energy based non-conventional machining processes. Okay, and fourth is the ultrasonic machining process. Okay, so these are the 4 processes which are we are going to learn in the unit number 3. Sorry, unit number 2. Okay, now apart from this 4, we have the another, that is abrasive flow machining, that is AFM. That is not a part of our syllabus. Then abrasive magnetic abrasive finishing, MAF. Okay, so that is also part of the mechanical energy based processes. Okay, AFM and MAF. Okay, abrasive flow machining, and second is the magnetic abrasive finishing. Okay, now in short, here I have written AJM is what? Abrasive jet machining. WJM is what? Water jet machining. And the combination is called abrasive water jet machining. And last is the USM, ultrasonic machining. Now for all these 4 processes, we need to study it's a working principle, then it's a system, or we can call equipments used for this your system or process, then what are the different process parameters. That means what is your input, okay, what is your output of the your machining, and how it is going to change. That in detail we are going to see. That is in short I can call fishbone diagram of all the processes we are going to see. Okay, now out of different process parameters, one parameter is very important, and that is called material removal rate. Material removal rate. It is in short it is called MRR, material removal rate. Okay, so how that material removal rate is going to vary, okay, with respect to other process parameter, that is also we are going to see. Okay, and we are going to see some different ideal cases. Okay, so that we'll get the some standard graph also. Okay, so that is a hidden part of our syllabus that we are going to see how, for example, if we change the velocity of j, how our material removal rate is going to change with respect to some copper material or wood material or aluminum or steel. Okay, for different different material, you will get the different profile of your graph. Okay, so that we are going to see in detail here. And at last, we are going to see what is the advantages, disadvantages, applications of all these four processes. Okay, if you take when I will start with the average jet machine. So in that we are going to introduction, working principle, equipment used, or setup of the average jet machining. Then which are the different process parameters, material removal rate. Okay, then advantages, applications. Likewise, sequence will be there. Okay, so this is the second unit. Then third unit. Now this third unit, it is a part of thermoelectric energy based non-conventional machining, or we can call electrothermal energy based. But as per syllabus, electrical energy based processes are there. Now in this chapter, okay, electrical based means what? Electrical energy is used to remove the material from the workpiece. Okay, now how using electric energy, how we are going to remove the material, that we are going to learn. Now under this category or under this group, as per the syllabus, we are going to see the two processes. Okay, that is very important. This electric discharge machining, EDM. Okay, in many industries, this EDM it is used. Okay, all the whatever the syllabus is there, that is important, because in industry to do the faster operation in minimum time, as well as to get the maximum material removed. Okay, within short time we want to remove the all material or maximum material. So for that purpose we need the advanced machining, and that advanced machining is for processes. So depend on the again which energy we are using, so we have the classification. Okay, in detail we are going to see in the chapter number 1. Okay, because of that I'm just giving here overview or outline, I can say. In detail I am not going here, because our chapter 1 is the overview. Okay, if I will teach the classification here itself, okay, that means our first one will go. Okay, but that I'm not doing here. Just I will take overview, and during the when time will come about chapter number 1 in detail, we are going to see how this classification, how it is grouped and all this thing. Okay, I was talking about the chapter number 3 or unit number 3, electrical energy based non-conventional machining process. In that, we are going to see two machining processes. One is the electrical discharge machining. In short, remember the short form of all the processes. EDM is what, ACM is what, or AJM, WJM, and all these things. Okay, so electrical discharge machining was EDM, and the extended version of this EDM is what, wire cut EDM or wire EDM also we can call. Okay, for these both processes, we are going to see the in this introduction, then working principle, then it's the setup, or we can call equipment used, then what are the process parameters, then material removal rate, how it is going to change. Okay, that is and then which electrodes material we are going to use. Okay, which tool we are going to use, how that tool will be there. So that part we are going to then here the most important is the dielectric fluid, and how that dielectric fluid is going to flush on the workpiece or that machining compartment, that we have to see. Okay, now, and that last is the applications. Okay, so now just remember the new words, that dielectric flushing or just material removal rate, MRR. Okay, because in detail we are going to see. Okay, this is just I am giving the outline. Okay, now you are thinking, you may think that what is that dielectric fluid? Okay, no need to think, because in detail we are going to see. Okay, just see the words, new things. So these are the three chapters, three units belongs to unit number one. So section number one. Then under section number two, we have the first chapter or totally chapter number or unit number four. That is chemical and electrochemical energy based non-conventional machining processes. Okay. Now, if you use this chemical energy, then there will be the chemical machining process. Okay. Then if you use electrical energy along with the chemical, then electrochemical machining will be there. In short, for the this chemical machining, we are calling CHM. For electrochemical machining, ECM. Okay, and then again hybrid version of the electrochemical machining, it is called, that means that if you combine the advanced machining along with the conventional machining, we'll get the some another machining process. It is called the hybrid machining. So electrochemical machining, if it is used for the grinding purpose, okay, using the grinding wheel, then it is called electrochemical grinding, ECG. That is also part of our syllabus. And the last is the very interesting, that is a photochemical machining. Photochemical machining. Okay, PCM. Okay. Now the facility of this photochemical machining, it is available in our mechanical engineering department. Okay, many students, if you consider the 35 group project group every year, then out of 35, minimum 8 to 6 or 6 to 8 group are working on this photochemical machining. They are doing the project on this because we have the facility of this all for machining of this process. Okay, so you can change material and you can take different uh, that configuration for your material. Okay, so here we have the scope or PCM. Okay, now this electrochemical grinding we don't have that EHM or other thing. EDM also we don't have, but if you want to go for any project, then near to our college is the WC Sangli. In that campus, we have this facility. Okay. Again, for this all four processes, same way we are going to see this introduction, working principle, setup. Okay, for the all these processes, we need some chemical. It is called etchant. Okay, mascant. Okay, so what is my etchant and mascant? I'm going to tell in detail about that also. Okay, then how we are going to apply that mascant on the workpiece. That is also the one different techniques are there. Okay, screening is there, and that now that photochemical machining is there. No, that is a part or a technique of applying masking. Okay, so that is belongs to the chemical machining. In detail, we'll see. And then process parameters and how material removal is going to change with respect to different process parameters. That is also we are going to learn. And at last, we are going to see the applications of this all processes. Okay. So this is the syllabus of chapter number 4. Then unit number 5. Now, unit number 5, in that in this unit we are going to see the thermal energy based non-conventional machining process. Okay. Now in that thermal means what? Laser beam machining, LBM. Then plasma arc machining, PAM. Ion beam machining, okay, IBM. And fourth is the electron beam machining, EBM. So these are the 4. Okay. These four plus 2 from electrical group. So combinedly, I can call thermoelectric energy based non-conventional machining process. Okay. Again, for this four processes we are going to learn. It's introduction, working principle, setup, equipment used. Okay, then for laser beam masting, we have the different beam control techniques that also we are going to see, and then it's input and output parameters, process parameters we can call it, material removal, and at last application. Okay, so up to this unit number 5. So this is syllabus advanced. This is syllabus of advanced machining processes or non-conventional machine processes. Okay, so up to this chapter number 5th, we are going to learn 14 different advanced machining processes. Okay, 14. And last chapter or last unit is the introduction to coating technology. Okay, so this chapter totally belongs to the our surface engineering stream. Okay, so this is just an introductory chapter. In that we are going to see a principle of coating technology, then its mechanism. Okay, then it's the classification. Now after classification you will get the two group or two type, that is a chemical vapor deposition and physical vapor deposition. Okay, then in that again we are going to see its application and further sub classification also. Okay, that is hidden part of this CVD. In short we can call CVD, that is chemical vapor deposition, and for PVD means what? Physical vapor deposition. Okay, it's a sub classification also we are going to learn. Okay, then we have the another coating technology, that is metal spraying, then metallic coating. Okay, and at last thermal spraying. Okay, thermal spraying, not in that again sub part is that plasma spraying and flame spraying. Okay, so here also four processes or four techniques. CVD, that is the chemical vapor deposition, then physical vapor deposition, then metal spraying, metallic coating, and thermal spraying. So five techniques we are going to learn in the chapter number 6. Okay, so this is our syllabus of our subject, non-conventional machining. Okay, then term work part, that is ICA part. So as per the curriculum of our university, okay, here we don't have any practical, okay, to perform. Okay, just the theoretical assignments are there, and total 8 assignments you have to write. Okay, now again in that total 8, minimum 6 assignments should be there based on the above 6 topics. That means for every unit you have to write one assignment for our term or part. Okay, so here in our institute we are calling assignment, that is the assignment part, that is institute policy. But here term work assignment is what? That is a university, that is a term work part. That means here these assignments you have to write in your journal. Okay, so I'm going to give or I'm going to give some case studies batch wise. Okay, some practical oriented questions. I'm not only theoretical. Okay, whatever you are going to learn in the, for example, in chapter number 1 you are going to learn classification. So that classification question I'm not going to give in this assignment. Okay, I will give some case study type. For example, if you have one block of MS material, and if you want to cut that block or that plate into the 6 different or similar uh, uh, part, okay, then you need to suggest one best advanced machining process. Okay, and no need, not only you have to suggest, you have to justify that answer. Okay, some students will tell that abrasive jet machining process it is best suited for cutting of the MS plate. Okay, some students may tell that chemical machining, through chemical machining also possible. Okay, some students will tell ECM, some students will tell LBM. Okay, so all answers will be correct, but out of that we have to justify the best one. Okay, so like that I'm going to give the practical oriented assignment questions, and we are going to discuss on that also during the our practical. So 6 assignments. Now for remaining 2 assignments we have to go for the 2 case studies. Okay, now case studies, now for what purpose we have to go for this case studies? So to discuss the effect of process parameters. Okay, effect of process parameters on material removal rate, that is MRR. of non-conventional machining process. Okay, so you have to go for the case studies. Now, how to do this case study? Okay, here I will tell the one example. Simply, you can search some reputed journal research papers. Now, reputed means what? Your in the SCI journal paper or SCIE or Scopus. Okay, if you search on our ASME portal or IEEE website or our Science Direct, okay, in your paper. So all the papers which are you are getting on that portal, that is a reputed journal paper. So you have to select AGM process, abbreviate must, for example, or EDM, we'll take the EDM. So related to EDM, you can search 5 to 10 papers. Okay. Now in that also, you need to study only effect of process parameter on the MRR. Okay. Effect of process parameter on MRR. Okay. And by studying these all 5 papers, you have to write 2-3 pages. That means in chapter in paper number 1, for example, you have to write the title of paper, who is the author, and what was the its object, okay, objective. Okay, now to achieve the objective, what he has gone for the methodology, and then what was the its result, that you have to write. Okay, so like that you have to go for the case studies. Okay, so here you have some you have freedom, you can consider AJ any uh, advanced machine process. Okay, because we are going to learn 14 out of 14, you can take 1 2. Okay, so 2 case studies you have to write. Okay, you have to search minimum 5 reference, sorry, research paper from journal, reputed journal. Okay, you will get from Science Direct website. Okay, related to any 1 or 2 process, and in that you have to see how the that process parameter is going to affect on the your material removal. Again, in that metal to metal, okay, if you consider MSS or copper or aluminum or tungsten or other, okay, so metal to metal you will get the different uh, that the effect of process parameter on that. Okay, you will get different graph also. So this is a part of our term more. Okay, now being a final year students, you should know the textbook as well. We can call reference book also. Okay, uh, so as per my view, I can tell you that don't just depend on the class notes. Okay, go for the reading of the textbook or the reference book. Okay, because by reading the reference book or the textbook, you will get the additional knowledge. Okay, of that subject. Okay, so for that, for our subject, okay, I will recommend one book, that is the advanced machining process by VKJ, allied publisher. Okay, so this book VKJ, advanced machining process, VKJ book. Okay, in our central library we have more than 150 copies. Okay, for last time only we have purchased this book. Is very interesting. Okay, whatever I'm going to teach you, so all the points, or for all PPTs or for all points, I have taken the reference of this book, huh? I have read this book. Okay, so that book is simple language, understandable. Okay, and all syllabus covered in this book. Okay, all first 5 for uh, chapter number 6 we have the separate book. Then similar to your that vacation book, we have the another book, that is non-conventional machining by PK Mishra. Okay, Neuros of Publishing, that is also a good book, huh? Because PK Mishra has referred the we can call it some textbook or maybe some references from the VKGen, because VKGen is the, you can call, base of our advanced machining process. Okay. Then so this manufacturing science, okay, you may have gone for the this book for metal subject. Okay, Amitabh Ghosh and Millet. Okay, that book also available in our lab. Then for another, for those modern machines process, PC Pandey. Okay, Then some reference book. Okay, so another that non-traditional Muslim process by Gary Bendict. Okay, that book also good. Okay, they have got for some different research papers, and after studying or that different research papers, they have written the book. So there you will get the different case studies. Okay, and out of this, sorry, except this all, you can refer another book that is Production Technology by HMT. Okay, that book has written from the case studies from CMTI Bangalore Research Center. Okay, 2 to 3 copies, hard copies are available at our institute central library. Okay, you will not get a soft copy of this Production Technology by HMT. Okay, so you will get the soft copy of the this advanced machine process by VK Jain book. Then you will get the soft copy of the Gary Bendict book. Okay. Then we have the also another book that advanced machine process. Okay, by Hassan Ilufi. Okay, I have the soft copy of this book also. Okay, I am going to share you. Don't worry. So these all books you can refer for our syllabus. Okay, if you refer the VKGN book only, that is also fine. Okay, because that book will cover the all syllabus. Okay, except the chapter number 6. Okay, and again advancement of this our non-consumer machine process, that is called micro machining. If you want to, if you have interest of my in that micro machining, you can refer the this introduction to micro machining book by VKJ. Okay, that is also good book. If you have the knowledge of advanced machining processes, then it is easy to understand the micro machining also. Okay, those who want to go for the PG in the micro machining or the advanced, okay, then you can go in detail about this all the books. Okay, so this is a textbook. Here also again some reference book I have given. Okay, manufacturing process and system by PF Ostwald, the material science process in manufacturing. Okay, then advanced machining process by Hassan Elofi. Okay, that this introduction to manufacturing process, micro machining. So they are the reference book. Okay, now what are the our course outcomes of this our subject? So by learning the chapter number 1, okay, you will be able to summarize the different non-conventional machining processes. Okay, because first chapter is overview. So after studying that, you will be able to summarize the different non-conventional machining. Then after learning or after studying the chapter number 2, you will be able to select the suitable non-conventional machining process which is based on the mechanical energy source. Okay, select the suitable mechanical energy based process for suitable metal. Okay, for different metal, different process may be applicable. Okay, so that knowledge you will get the after studying the unit number 2. Then after studying or after learning the chapter number 3, you will be able to examine the EDM and wire cut EDM. Now EDM is what? Electric discharge machining, okay, and wire cut EDM process and their application. Then after studying the chapter number 4, okay, you will be able to explain the working principle, process parameters, and application of chemical machining, electrochemical machining, and photochemical machining. Okay, after studying the chapter number 5, you will be able to categorize the different non-conventional machining based on thermal energy sources and its the application. Okay, this is the outcome of your chapter number or unit number 5. And after studying the last chapter, that is the 6th chapter, you will be able to discuss the different coating methods. Okay, like CVD, that chemical vapor deposition, physical vapor deposition, metal spraying, metallic coating, and thermal spraying. So these are the course outcomes of our subject. Okay, this is a course outcome unit wise I have given here. Okay. So this is a syllabus. Now, uh, as I have taught this subject for last semester for TYBTech student, so I have recorded all the videos of my all lectures point wise, okay, of our syllabus. So you will get all the lectures, okay, on my YouTube channel, that is Let's Learn and Grow Together. Okay, if you write hash LLAGT hash DT Kashid at YouTube, you will get all my lectures. Okay, so I will share the links also by point wise. So this is a syllabus. One minute. Okay. Now, before going to unit number one, okay, that is classification and all these things. Okay, you should know the why do we need this advanced machine processor, or why do we need a non-conventional machine processor? Okay. Now, again, before that, I will tell the conventional machining and non-conventional machining also. Okay, within 1 minute, I will cover that also. So that that whatever you learn point in the MP subject, that will be repeated. You can see here now. Okay, so we know that our manufacturing processes, okay, can be divided into two basic processes. One is a primary manufacturing process, and secondary manufacturing process. Okay, in short, I will tell. So, if you want basic shape and size on your or to the your work material, okay, as per the designer's requirement, then we can use the primary manufacturing processes. Now, which are the processes which is required for a basic shape and size? Okay, so generally you are generally that casting and forming, powdering. So all these are the your primary manufacturing processes. And secondary manufacturing is what? Okay, this will provide the final shape and size with the tighter control on dimension. Okay, if you want final shape as well as dimensional accuracy with surface characteristics, then we can use the secondary manufacturing process. Again, in that secondary manufacturing process, we have the metal removal processes. Okay, we have the metal removal process, because this metal removal process is the mainly belongs to our secondary manufacturing process. Now, again, in that secondary, as I mentioned, that metal removal process, that metal removal process are divided into the mainly two parts. or two groups. One is the conventional and second is a non-conventional or non-traditional. Okay. Now conventional means what? These processes mostly remove the material in the forms of chips. Okay. Now how material is going to remove? By applying the force on whom? On the workpiece. Okay. With the edge-shaped cutting tool. Okay. And here basic condition of this conventional machining is that your cutting tool should be harder than your workpiece. Okay. Then and then only you can remove the material from the your workpiece. Okay. And so here I will tell some examples of your conventional machining. Okay. So at starting I have told that turning, boring, milling, shaping, slotting, grinding, all these are the your conventional machining process. Now in at another side, what is the non-traditional machining process? So this is a group of process that remove the excess material by various techniques which are involving mechanical, thermal, electrical, or chemical energy, or combination of these energies. But okay, you can use this energy, but no need to use the sharp cutting tool. Okay, as like it is used in traditional machining process. So this category is called non-traditional machining. Here we don't need that cutting tool, okay, which is that edge-shaped cutting tool, okay, having the hardness uh, more than the workpiece. Here there is no condition like that. Okay, so which are the some examples? Okay, AJM, EDM, ECM, LBM, EJ, EBM. Okay, that is non-traditional machining process. Okay, here just I have given the overview. Now I think at 4:45 you have another lecture. You quickly I will take the attendance. Okay, in next lecture we'll go for the further part of this point. Okay, now wait, I will take attendance.